WebSocket is a computer communications protocol, providing full-duplex communication channels over a single TCP connection. The WebSocket protocol was standardized by the IETF as RFC 6455 in 2011. And the WebSocket API in Web IDL is being standardized by the W3C. WebSocket is distinct from HTTP. Both protocols are located at Layer 7 in the OSI model and depend on TCP at Layer 4. Although they are different, RFC 6455 states that WebSocket is designed to work over HTTP ports 443 and 80 as well as to support HTTP proxies and intermediaries, thus making it compatible with HTTP. To achieve compatibility, the WebSocket handshake uses the HTTP upgrade header to change from the HTTP protocol to the WebSocket protocol. The WebSocket protocol enables interaction between a web browser or other client application and a web server with lower overhead than half-duplex alternatives such as HTTP polling, facilitating real-time data transfer from and to the server. This is made possible by providing a standardized way for the server to send content to the client without being first requested by the client, and allowing messages to be passed back and forth while keeping the connection open. In this way, a two-way ongoing conversation can take place between the client and the server. The communications are usually done over TCP port number 443 or 80 in the case of unsecured connections, which is beneficial for environments that block non-web internet connections using a firewall. Similar two-way browser-server communications have been achieved in non-standardized ways using stopgap technologies such as Comet. Most browsers support the protocol, including Google Chrome, Firefox, Microsoft Edge, Internet Explorer, Safari and Opera. Unlike HTTP, WebSocket provides full-duplex communication. Additionally, WebSocket enables streams of messages on top of TCP. TCP alone deals with streams of bytes with no inherent concept of a message. Before WebSocket, Port 80 full-duplex communication was attainable using Comet channels. However, Comet implementation is non-trivial, and due to the TCP handshake and HTTP header overhead, it is inefficient for small messages. The WebSocket protocol aims to solve these problems without compromising the security assumptions of the web. The WebSocket protocol specification defines WS WebSocket and WSS WebSocket Secure as two new Uniform Resource Identifier (URI) schemes that are used for unencrypted and encrypted connections, respectively. Apart from the scheme name and fragment, i.e. hash is not supported. The rest of the URI components are defined to use URI generic syntax. Using browser developer tools, developers can inspect the WebSocket handshake as well as the WebSocket frames. History. Edit. WebSocket was first referenced as TCP connection in the HTML5 specification as a placeholder for a TCP-based socket API. In June 2008, a series of discussions were led by Michael Carter that resulted in the first version of the protocol known as WebSocket. The name, WebSocket, was coined by Ian Hickson and Michael Carter shortly thereafter through collaboration on the #WHATWGIRC chat room, and subsequently authored for inclusion in the HTML5 specification by Ian Hickson. In December 2009, Google Chrome 4 was the first browser to ship full support for the standard, with WebSocket enabled by default. Development of the WebSocket protocol was subsequently moved from the W3C and WHATWG group to the IETF in February 2010. and authored for 2 revisions under Ian Hickson. After the protocol was shipped and enabled by default in multiple browsers. The RFC 6455 was finalized under Ian Fett in December 2011. RFC 7692 introduced compression extension to WebSocket using the deflate algorithm on a per-message basis. Browser implementation. Edit. A secure version of the WebSocket protocol is implemented in Firefox 6, Safari 6, Google Chrome 14, Opera 12.10 and Internet Explorer 10. A detailed protocol test suite report lists the conformance of those browsers to specific protocol aspects. An older, less secure version of the protocol was implemented in Opera 11 and Safari 5, as well as the mobile version of Safari in iOS 4.2. The BlackBerry browser in OS 7 implements WebSockets. Because of vulnerabilities, it was disabled in Firefox 4 and 5. And Opera 11. JavaScript client example. Edit. Web server implementation. Edit. Nginx has supported WebSockets since 2013. Implemented in version 1.3.13 including acting as a reverse proxy and load balancer of WebSocket applications. Apache HTTP Server has supported WebSockets since July 2013. Implemented in version 2.4.5. Internet Information Services added support for WebSockets in version 8, which was released with Windows Server 2012. Lite TPD has supported WebSockets since 2017. Implemented in version 1.4.46. Lite TPD mod _proxy can act as a reverse proxy and load balancer of WebSocket applications. Lite TPD mod _WS tunnel can facilitate a WebSocket tunnel, allowing a client to employ WebSockets to tunnel a simpler protocol, such as JSON, to a backend application. Protocol handshake. Edit. To establish a WebSocket connection, the client sends a WebSocket handshake request, for which the server returns a WebSocket handshake response, as shown in the example below. Client request. Just like in HTTP, each line ends with RN and there must be an extra blank line at the end. Server response. The handshake starts with an HTTP request response, allowing servers to handle HTTP connections as well as WebSocket connections on the same port. Once the connection is established, communication switches to a bidirectional binary protocol which does not conform to the HTTP protocol. In addition to upgrade headers, the client sends a SEC WebSocket key header containing base 64 encoded random bytes, and the server replies with a hash of the key in the SEC WebSocket accept header. This is intended to prevent a caching proxy from resending a previous WebSocket conversation, and does not provide any authentication, privacy, or integrity. The hashing function appends the fixed string 258EAFA5E91447DA95CAC5AB0DC85B11 AUUID to the value from SEC WebSocket key header, which is not decoded from base 64, applies the SHA-1 hashing function, and encodes the result using base 64. Once the connection is established, the client and server can send WebSocket data or text frames back and forth in full duplex mode. The data is minimally framed, with a small header followed by payload. WebSocket transmissions are described as messages, where a single message can optionally be split across several data frames. This can allow for sending of messages where initial data is available but the complete length of the message is unknown. It sends one data frame after another until the end is reached and committed with the fin bit. With extensions to the protocol, This can also be used for multiplexing several streams simultaneously. For instance, to avoid monopolizing use of a socket for a single large payload. Security considerations. Edit. Unlike regular cross-domain HTTP requests, WebSocket requests are not restricted by the same origin policy. Therefore, WebSocket servers must validate the origin header against the expected origins during connection establishment to avoid cross-site WebSocket hijacking attacks, similar to cross-site request forgery, which might be possible when the connection is authenticated with cookies or HTTP authentication. It is better to use tokens or similar protection mechanisms to authenticate the WebSocket connection when sensitive, private data is being transferred over the WebSocket. A live example of vulnerability was seen in 2020 in the form of cable haunt. Proxy traversal. Edit. WebSocket protocol client implementations try to detect if the user agent is configured to use a proxy when connecting to destination host and port, and, if it is, uses HTTP connect method to set up a persistent tunnel. While the WebSocket protocol itself is unaware of proxy servers and firewalls, it features an HTTP-compatible handshake, thus allowing HTTP servers to share their default HTTP and HTTPS ports 80 and 443, respectively, with a WebSocket gateway or server. The WebSocket protocol defines a WS and WSS prefix to indicate a WebSocket and a WebSocket secure connection, respectively. Both schemes use an HTTP upgrade mechanism to upgrade to the WebSocket protocol. Some proxy servers are transparent and work fine with WebSocket. Others will prevent WebSocket from working correctly, causing the connection to fail. In some cases, additional proxy server configuration may be required, and certain proxy servers may need to be upgraded to support WebSocket. If unencrypted WebSocket traffic flows through an explicit or a transparent proxy server without WebSocket support, the connection will likely fail. If an encrypted WebSocket connection is used, then the use of transport layer security (TLS) in the WebSocket secure connection ensures that an HTTP connect command is issued when the browser is configured to use an explicit proxy server. This sets up a tunnel, which provides low-level end-to-end TCP communication through the HTTP proxy between the WebSocket secure client and the WebSocket server. In the case of transparent proxy servers, the browser is unaware of the proxy server, so no HTTP connect is sent. However, since the wire traffic is encrypted, intermediate transparent proxy servers may simply allow the encrypted traffic through. So there is a much better chance that the WebSocket connection will succeed if WebSocket Secure is used. Using encryption is not free of resource cost, but often provides the highest success rate since it would be traveling through a secure tunnel. A mid-2010 draft version HXE 76 broke compatibility with reverse proxies and gateways by including 8 bytes of key data after the headers, but not advertising that data in a content length 8 header. This data was not forwarded by all intermediates, which could lead to protocol failure. More recent drafts, e.g., HIB09, put the key data in a SEC WebSocket key header, solving this problem. See also. Edit. Notes. Edit. If you like this video, please like and subscribe and turn on notifications.